Hi everyone, my name is Kevin, and I wanted to walk you through an example of a tutoring session using an Algebra 2 problem. Now, during our actual tutoring sessions, of course, it'll be much more of a discussion. I'll be asking you questions, and we'll be thinking through the problem together. For today, I'll be walking you through how I might think through this problem and a bit about my thinking process as well. So for today, we'll go through an Algebra 2 problem, and this problem covers two topics within Algebra 2. The first being determining zeros of polynomial equations, and the second being able to plot zeros on a graph. So the question here says, plot all zeros of the equation y equals 3x cubed plus 9x squared minus 12x on the graph. Now, the first thing I'm actually going to do here before we go into the specific question is list out the things a person would need to know or be able to do to actually be able to successfully answer this question. I'll explain why in a second, but let's go ahead and just go through, hey, what would I need to know or be able to do to actually be able to plot all zeros of that equation on the graph, right? The first thing you're going to need to know is, well, what is a zero? Right. The second thing you're going to be able to need to know how to do is to solve for zeros. Right. We'll see what this means in a second, but you're going to need to know how to solve for zeros using factoring. And because there is always more than one way to solve a problem, you could also solve for zeros here using the quadratic formula. Again, we'll go through what this means, but just want to list out, hey, if you're actually going to be able to solve this problem, you're going to need to know how to solve for zeros. All right, so what else do you need to know aside from what a zero is and being able to solve for zeros using factoring and or the quadratic formula? You'll also be able to know how to graph zeros. All right, now why do I go through this process of listing out what knowledge or skills are needed? Well, first, when we go through a tutoring session, we may or may not list out all of these before each question. It's going to kind of be up to you and your own learning style. But what this enables me to do is really be able to assess where you are and kind of tailor our sessions to what your needs are and how fast you may want to go through the material, right? So I'll ask questions to kind of get a sense of, hey, does this person know these essential pieces of knowledge or skills? And by doing that, we'll be able to tailor the session to you, go at your speed, and also focus on those areas where you may have some knowledge or skill gaps, right? Because the objective here is not just to make sure that you get this question right, it's to make sure that you have all the knowledge and skills to be able to answer all questions that are like this correctly, right? Just making sure that you have that full toolkit. Okay, so let's dig into the question here. Plot all zeros of the equation y equals 3 cubed plus 9x squared minus 12x on the graph. Well, let's start with the first thing. Let's define what is even a zero. Okay. And there's two ways to think about what a zero is. And I'll say one way is to think about it graphically. And another way is to think about it by looking at an equation. Okay, let's start with this first one of graphically. What does that mean to be a zero when I look at a graph, right? Just for an example here, I'm going to show you the graph of y equals x squared minus 9, all right? If I were to put that on the graph here, it would look something like that. All right, so what is a zero? Well, if I'm looking at a graph, all a zero means is when does the graph of an equation cross the x-axis? All right, so if I'm looking at this graph here, well, what are its zeros? It's really just where this graph crosses the x-axis. So where does that happen? That happens at this point right here and at this point right here. If I put what those coordinates are, it's 3, 0, and this one right here is negative 3, 0. All right? So all a zero is, hey, where does the graph cross the x-axis? What are its x-intercepts? And using this example here of y equals x squared minus 9, we know that the zeros are negative 3, 0, and 3, 0, because that's where it crosses the x-axis. Easy enough. That's all it means graphically, is where it crosses the x-axis, those are its zeros. All right? Let's think about zeros in a different way. Let's think about it from the perspective of looking at it at an equation, right? So if I were to look at the zeros here, what do we notice is the same about our 2 points here that where it crosses the x-axis, -3, 0 and 3, 0. Well, we notice that the y-coordinate is always equal to 0. The y-coordinate is always equal to 0 whenever you have an x-intercept. Now, how does that help from an equation perspective? Well, if I know that our y is always going to be equal to 0 whenever we have an x-intercept, I then know, well, if I were to look at this equation up here, if I made y equal to 0, and made this 0 equals to x squared minus 9, if I were to solve that equation, it would give me the x-intercepts. And in fact, if you were to solve that, you would find out that you would get the answers to be 3 and -3, which is exactly, again, where our graph crosses the x-axis. All right, so that's what a 0 is. From a graphical perspective, it just means, hey, where does your graph cross the x-axis, the x-intercepts? And from an equation perspective, it really means, hey, for what values of x will make your equation equal or have y equal 0, right? So those are two ways of really understanding, well, what is a 0? Now, what we'll go ahead and do is, let's look at our problem here and see what it's asking. It's saying plot all zeros of that equation. Well, before we can plot the zeros of that equation up there, let's go ahead and determine what the zeros are. Do we have a way to determine what the zeros are? Well, I don't know what the graph looks like of this equation. So let's use our other definition here, recognizing that, hey, the zeros for this equation here will be whenever y is equal to 0. Right? So let's go ahead and set up that equation. So our original equation here is y is equal to 3x cubed plus 9x squared minus 12x. Right? Again, I know to find my zeros, that is when y is equal to 0. All right. So I'm going to set my y equal to 0. And now I just want to solve for x. Now, how do I solve for x here? Well, we're going to use some factoring, right? So if I look at my right-hand side, what can I factor out of those three terms there? It looks like in terms of the coefficients, I could probably factor out a 3. In terms of the variable, I can factor out an x. Okay, so 3x times what gets me 3x cubed? It's going to be x squared. 3x times what gets me 9x squared? It's going to be positive 3x. And then 3x times what gives me negative 12x? That's going to be minus 4. Right now, of course, you could check that, distribute that 3x across that other factor, and you should get right back to the original equation. Okay? Now, let's remember here why factoring even helps or even works. Let's remember any two things, when you multiply them together, right? So here's our first term, here's our second factor here. If either of those factors is equal to 0, well then 0 times anything equals 0, right? So why is that helpful here? Well, then I know if this first factor of 3x, if that's ever equal to 0, well, that'll make this equation true, right? Doesn't even matter what my second factor is. If my first one is 0, well, for sure I'm going to get an answer of 0. And it's also true for the second one as well. If x squared plus 3x minus 4 is equal to 0, that'll make this equation true as well. All right? So we have a couple different equations here we could go ahead and solve. So 3x is equal to 0, we'll divide both sides by 3. You have x is equal to 0. Great, we found our first 0. If when x is equal to 0, for the graph of this equation, it will cross the x-axis. It will be an x-intercept, all right? Let's see if we have any more. So we have x squared plus 3x minus 4 is equal to 0. How can I solve this? Well, some additional factoring. All right, so what two numbers, when I add them together, will give me positive 3, and when I multiply them together, will give me a negative 4. It's going to be plus 4 and minus 1. Right? And of course, you could FOIL to make sure that that turns out to be correct. Right? So x plus 4 is my first factor, and x minus 1 is my second factor. I could set both of those equal to 0. All right. As I solve this, I have that x is equal to negative 4, and also x is equal to positive 1. Great. So now what has this told me? As I set y equal to 0 here and solved for x, I have 3 different zeros, different x-intercepts here. And I know that when I look at the graph of this equation, y equals 3x cubed plus 9x squared minus 12x, it will cross the x-axis at these 3 points, at x equals 0, at x equals negative 4, and at x equals 1. Right? So now we've determined the zeros of this equation by setting y equal to 0. Right? Now, final part, this is saying to plot all of those zeros onto the graph. Now, note here, it's not asking us to put the whole graph of the equation. It's just asking us to plot the zeros. All right? And we know what those zeros are. We just solved them down below. We know that it's going to cross the x-axis at 0, at negative 4, and at positive 1. Right? Let's go ahead and list out those coordinates as well. 1, 0, 0, 0, negative 4, 0. And that's it. We don't have to put down the whole graph of the equation. It just asks us to plot the zeros. And we know that those are the points where this graph is going to cross the x-axis. So again, what did we do today? We talked about, hey, what is a zero? And we understood that just means that it's when the graph crosses the x-axis. And from an equation perspective, that really means setting y equal to 0. We went ahead and we went through an example of actually solving the zeros for an equation by setting y equal to 0, and we found out that we had 3 different zeros or 3 different points where this graph would cross the x-axis. And the final thing we did was we just went ahead and plotted those 3 points where this graph will cross the x-axis onto the coordinate plane. Right? So that's all you need to know. I'll just share with you, just so you can see it, the actual full graph for this equation will look something like it. Actually goes beyond the bounds of the graph here. But it looks something like that. Right? Again, all you needed to do was plot the zeros of this. But if you were to plug in that equation to your graphing calculator as well, you would see that, hey, that is in fact where this graph crossed the x-axis.